4.6 billion years ago, a giant cloud of gas and dust collapsed after a nearby supernova. Most of the mass pulled inward to ignite the Sun, while the remaining debris formed a spinning protoplanetary disk. In the hot inner regions, only rock and metal could solidify, creating the terrestrial planets. In the freezing outer reaches, ices and gases gathered to form the gas and ice giants. Through billions of years settled into the orderly solar system we see today. At an average distance of 58 million kilometers, Mercury is the Sun's closest companion. It is a world of physical extremes. Because it is so small, its core cooled quickly, but surprisingly, that core makes up 85% of the planet's radius. It is a dense ball of iron covered by a thin rocky crust. With almost no atmosphere to trap heat, temperatures swing wildly from 430 degrees Celsius in the day to minus 180 degrees Celsius at night. Venus orbits at 108 million kilometers. On paper, it's Earth's twin, similar size, gravity, and composition. But the similarity ends there. Venus is wrapped in a suffocatingly thick atmosphere of carbon dioxide, with clouds of sulfuric acid. This creates a runaway greenhouse effect, trapping solar heat and pushing surface temperatures to a constant 475 degrees Celsius, hot enough to melt lead. The atmospheric pressure is 90 times that of Earth. Standing on the surface would feel like being 3,000 feet underwater. It is a volcanic wasteland where the Sun is never seen through the permanent golden haze. Sitting in the Goldilocks Zone at 150 million kilometers, Earth is a geological masterpiece. It is the only planet with a dynamic crust made of tectonic plates that recycle carbon, preventing the extreme fates of Venus or Mars. Its structure consists of a solid iron inner core, a liquid outer core that generates a protective magnetic field, a thick mantle, and a thin life-bearing crust. Why is it habitable? It's a perfect storm of conditions. The right distance for liquid water, a magnetic shield against solar radiation, and a moon that stabilizes our tilt, ensuring predictable seasons. Mars sits 228 million kilometers from the Sun. Its red color comes from iron oxide, essentially rust, covering its surface. Beneath the dust, Mars is a rocky world with a core that is no longer geologically active. It features the largest volcano in the solar system, Olympus Mons, and a canyon system that would stretch across the entire United States. Though it is cold and its atmosphere is 100 times thinner than Earth's, evidence shows that liquid water once carved its valleys. Today, that water remains locked away as ice at the poles and beneath the soil, waiting for the next chapter of exploration. Between Mars and Jupiter lies a vast, no-man's land. The asteroid belt contains millions of rocky fragments. While movies show them packed closely, they are actually millions of miles apart. These are the broken dreams of a planet. Jupiter's massive gravity was so strong that it prevented these rocks from ever coalescing into a single world. Jupiter is a monster of gravity, orbiting at 778 million kilometers. It is a gas giant, meaning it has no solid surface to land on. It is made mostly of hydrogen and helium, much like a star. Deep inside, the pressure is so intense that hydrogen turns into a liquid metal. Its most famous feature is the Great Red Spot, a storm twice the size of Earth that has raged for over 300 years. Jupiter acts as the solar system's vacuum cleaner, using its massive gravity to pull in stray comets and asteroids, often protecting the inner planets from impacts. At 1.4 billion kilometers, Saturn is the second largest planet and perhaps the most beautiful. It is another gas giant, so light that if you had a bathtub big enough, the planet would actually float. Its rings are not solid. They are trillions of chunks of water ice and rock, ranging from the size of a grain of sand to the size of a mountain. Scientists believe these rings may be the remains of a moon that was torn apart by Saturn's gravity. Saturn is a world of fierce winds, reaching speeds of 1,800 km per hour. Moving into the deep cold at 2.9 billion kilometers, we find Uranus. Unlike the gas giants, Uranus is an ice giant, composed of a hot, dense fluid of icy materials, water, methane, and ammonia, above a small rocky core. Methane in its atmosphere absorbs red light, giving the planet its serene cyan glow. Most strangely, Uranus rotates on its side, likely knocked over by a massive collision long ago. This means its poles experience 42 years of constant sunlight followed by 42 years of darkness. The final major planet, Neptune, sits 4.5 billion kilometers away. It is a dark, cold, and whipped by supersonic winds, the fastest in the solar system. Like Uranus, it is an ice giant, but its blue is more vivid, possibly due to an unknown chemical in its atmosphere. It was the first planet located through mathematical prediction rather than a telescope. Its largest moon, Triton, orbits the planet backward and is slowly being pulled toward Neptune, destined to one day be shredded into a new ring system. Beyond Neptune lies the Kuiper Belt, a dark graveyard of icy bodies and dwarf planets like Pluto and Eris. This region is a frozen time capsule, containing the most primitive materials from the birth of our solar system. It is the bridge to the Oort cloud, the outermost limit of the Sun's gravitational reach, reminding us that while we have mapped these 8 worlds, the true edge of our home is still a mystery.